Hey, how's it going there? Welcome to the final lesson of Unit 4, Lesson 4.3. And here's what 4.3 says. I can use composition by mass data to calculate the percent composition of a compound. So there's a really easy example we'll start with today. And the first thing I want to introduce is what is percent composition? Well, that's a fancy word for a specific type of fraction. If we take the part and we divide it by the whole and multiply it then by 100, what we get is a percentage value, and it'll tell you what percentage a certain element, or in this case, we'll see a certain color of candy is in a group of candies. All right, so here's the question we're going to answer now, okay? What is the percent composition of yellow Skittles in the sample to the left? All right, so here's what the question wants us to do. We're going to have to count the total amount of Skittles. That's our whole. And then the part is going to be the number of yellow. We'll take our calculator, we'll throw that in, we'll multiply by 100, and again, we'll get the then percent composition of yellow. So again, for the whole, count all Skittles. So just for the purpose of speeding up the video, we're going to make an assumption that there are 50 total Skittles. Okay, so there's 50 total. And now what we're going to do is count the yellows. So let's count together here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10 yellow. And at this point, what you're going to need is a calculator, and we're going to compute this together. So here's what we got to do. We have to do 10 divided by 50. That gives us 0.2, and we're not done yet. Remember, we have to multiply this value by 100. And what that's going to give us is 20%. So let's just throw that in our calculator to confirm that that's what it truly is. So 0.2 times 100. And indeed, it gives us 20%. So what is this value telling us? It's telling us this. 20% of the sample to the left is comprised of yellow Skittles. It's really that easy. So again, this is the answer to the question. So this was kind of a simple everyday example, but what we can do is we can extend this concept to compounds of chemicals. So here what we have is sugar, and below it here we have a single molecule of sugar. And ask yourself, is sugar a compound? What do you think? It is, because we see that there's different colored particles fused together, so sugar most definitely qualifies as a compound. And just as a side note, anytime we have two or more particles fused together, we will call it a molecule. All right. So what's the question asking? Here's what it says. Table sugar is a compound known as sucrose. Sucrose is composed of the elements carbon, hydrogen, and oxygen. Analysis of a 20-gram sample of sucrose from a bag of sugar finds that the sugar is composed of 8.44 grams of carbon, 1.3 grams of hydrogen, and 10.26 grams of oxygen. And then it says this expresses fractions, the ratio of the mass of each element to the total mass of the sample. Using these ratios, calculate the percent composition by mass of each element in the compound. Wow, that was totally a mouthful. And totally a lot of words, but if you could hang on with the example we did earlier with the Skittles, it's really just asking us the same thing. They want us to find the percent comp of carbon versus hydrogen versus oxygen. So remember, part over whole times 100 is our formula. And they told us that we have a 20-gram sample of sucrose. So this to me tells me that this is our total. And what they're really asking us in terms of finding the percent compositions is, what is the ratio of red to dark gray to light gray? So imagine these are Skittles. What's the percent comp of red Skittle? What is the percent comp of dark gray Skittle? And what is the percent comp of the light gray Skittle? So let's go ahead and let's label those. So your carbons are going to be dark gray. So we'll put the initials. Dark gray is carbon. Your hydrogens are going to be these light grays here. And then you guessed it, your oxygens are going to be the red ones. So what we want to do first, and we can start off with any of these, but we'll start off with carbon. We want to find the percent comp of the dark gray Skittle in comparison to the rest. So they tell us the masses instead of the actual count this time. So we'll write 8.44 grams. And then the total we said was 20 grams. So that's our first fraction. Now let's write fraction number 2. We have 1.3 grams of hydrogen, or the light gray. So that's my part. My whole is 20 grams. And now let's have our last fraction set up. 10.26 grams of oxygen. And again, the total is 20. So notice that now we're dealing not with specific quantities, but with masses. Molecules are so small that it'd be very tough for us to count individual pieces. So scientists have to use balances and masses, and therefore that's why these fractions look the way they do. So what I'd like you to do now is pause the video, compute these decimals, and when you unpause, you'll see my numbers, and let's see if we can get them to match up. Go ahead and pause the video. All right, so the the decimal that we should have came up with for carbon, if you round to tenths, was 0.42. For hydrogen, it's 0.07. And then for oxygen, you should have 0.51. So we're not done. The final step is we have to multiply all of these by 100. So go ahead and pause the video, multiply all those numbers by 100 each, and let's see if we can come up with the proper percentages and match. Go ahead and pause it. All right, welcome back. Here's what you should have come up with. Our sample here is 42% carbon, 7% hydrogen. So again, 7% of these light grays, 42% are these dark grays, and oxygen should have come out to 51%. And these are these red particles that we see in the diagram. Again, just to reinstate what we said earlier, because molecules and particles are so small, in a problem like this, you won't get quantities. What you'll get is masses. Will give you a total mass and 3 submasses that add up to the total. You'll have to set up your fractions, part divided by whole, multiply by 100, and then that should come up with your percentages of percent by mass of your sample. So I want to leave you with a tip, kind of an expert tip that can really help you verify if your answer is correct. Because percent by mass deals with percentage, we know that all of our percents should add up to 100. And this is a way that you can check this problem. So what I should be able to do is add 42 to 7 to 51, and depending on our rounding, we should either be at 100 or very close. So 42 plus 7 plus 51 actually does give us 100%. So again, add your percentages together, and to verify if you did this problem correctly and if your results are accurate, you should be either at or very close to 100%. So with that, we'll conclude the video. And as always, thank you for listening in and participating. Have a great day.